Okay, for today's video, I want to do a few more problems that involve the difference quotient. The situation is like this. You have something called f of x, that's a function or a formula, something like 1 minus 4x, like some kind of formula that involves the variable x. And we want to simplify this thing right here, okay? So that expression is called the difference quotient. So that's our job, is to work that out. I'll say a little bit about what's going on with that and why we're doing it. This has some relevance in calculus. If you keep taking math, this will be something you learn more about then. But how about for now, I'll say this. If we, say, continue to study science, engineering, and other math-related disciplines, a lot of what we have to do involves symbols. You know, here's a book on mechanical vibrations, all right? But I could get, almost any science or engineering book and show you the same thing. And there's, this is math, but there's lots of letters and symbols on the page. And if we're going to do any of the kinds of math that science and engineering involves, we have to get good at manipulating symbols. We have to get good at doing math with symbols and letters, okay? And that's what algebra is. Arithmetic is when you do math with numbers, and algebra is when you learn to work with the symbols. Okay, all right, so that's what's going on with the difference quotient. I'll say more about that when we do a problem. And so let's go ahead and look at my first example. Suppose the function, the thing you start with, is 1 minus 4x, and I want to simplify this, which is the difference quotient. Okay, so this says f of x plus h minus f of x all divided by h. How about before we do that, I'll focus on just this part, f of x plus h. The reason for that is h is just another variable, another symbol, and f of x is the name we give to the original function. So the only real controversy with this is f of x plus h. So I'll say a little bit about just that. So say I take that function, f of x, being 1 minus 4x. What is f of 2? Well, when we write function notation like this, f, I read that f of 2. That means that if 2 is the input in that function, what's the output? All right? What would you get if you put 2 in that formula? And what do I mean by, say, put it in that formula? Well, we could think of a formula like this if you want to. The x just signifies where the input goes. Okay? You might rather think of it like that. That in this function, whatever you would like the input to be, it's going to go in that empty spot right there, and then you're going to do the math. All right? So what is 1 minus 4 times 2? What's 1 minus 8? That'd be negative 7. All right? So that's what a function is. You put a number in, you get another number back out. Sometimes we say you put x in, and you get y back out or something like that. All right. So I'll put the 2 right there. I'll put the input right there. What about f of a minus b? Well, when you put a number in, it's probably easy to understand what's happening. Can you put other symbols in? Yeah, remember I said we need to learn to work with symbols, letters. That's what algebra is. So I'll treat this input or that one exactly like the 2. I'll put it in the same spot. All right? So you could think of it like this. 1 minus 4, and I'll even, just for emphasis, say, all right, well, the input is a minus b, okay? And it's supposed to go right there. That's where the input goes in the function. So that's where I put this. This signifies what the input's going to be. That's where it's going to go. 1 minus 4, a minus b. Okay, so can we do anything with that? Like when I put the 2 in, I say, well, 4 times 2, that's 8, and 1 minus 8 is negative 7. Okay, So can I do anything here? Well, I could, with the way this is, distribute the 4. So I'll get 1 minus 4a, negative 4 times a, plus 4b. Okay. What about f of x plus h? Well, it should be the same, right? No matter what the input of the function is, whether it's 2 or a minus b or x plus h or anything, it goes in the same spot in the function. It goes where the x was, all right? So this will be 1 minus 4x plus h. Okay, can we do anything with that? Well, like this one up here, we can distribute. So I get 1 minus 4x minus 4h. Okay. All right, so hopefully then, if you didn't already know, you see what it means when we put something right there. That's what we want the input to be, and that's how we handle it. Let's go back here. Okay, the difference quotient. It says take f of x plus h minus f of x and divide it by h. Okay? So let's get each one of those parts and put all that together. What is f of x plus h? What do you get when you plug x plus h into that formula? Well, that's what I was just talking about over here. This is how it's done. That's what you get. 1 minus 4x minus 4h. Okay. What's next? Minus. See that minus right there? Okay, so we have a minus. And what comes after that? F of x. F of x is the name, the label of this original formula. So 1 minus 4x. Okay, now I need to point something out to you. This minus in the difference quotient applies to all of that if that should have more than one term. So I'm going to emphasize something here with my red pen that minus applies to everything in there. So look, I've got everything from the difference quotient. Okay, let me label it for you. This right here, that's f of x plus h. And this part in there in the red parentheses, that's f of x. And then that's h. Did I get everything? Yes, got f of x plus h. I got that minus. I got f of x. I told you the minus applies across all that. And I got h. That's everything. Okay? Now I'll just need to reduce this as much as possible. So there's nothing I can do with that. So I'll just have to copy down 1 minus 4x minus 4h. Okay? But this other thing, remember I said that minus applies to all this. It distributes in there. What's the opposite of 1? That would be negative 1. What's the opposite of negative 4x? That'd be positive 4x. Okay, so there. Now we took care of that. Can you do anything else with it? I see that there are some terms that will cancel. 1 minus 1, negative 4x, positive 4x. What's left? Well, all that's left is a negative 4h on top and an h on the bottom. These h's cancel. Okay? Why? Well, because that's 4 times h divided by h, and division is the opposite of multiplication. That's why they cancel. So we cancel those, and negative 4 is the final simplified result of the difference quotient. Okay, let's look at another problem that's kind of on the other end of the spectrum of difficulty with this. What about that one? Okay, there's our function. Simplify the difference quotient again. Okay, well let's try to work this out ahead. All right, this f of x plus h, that's the only part that is of any difficulty in this, I think. So here's our function. Let me write it down here. So I'm going to get x squared plus 2x minus 1, okay? And what's f of x plus h? Let's just do that part, okay? What do you get when you plug in x plus h into that formula. Well, again, what does it mean to plug something in to this formula? Where does it go? Any input in that formula goes where the x's are. So it may help you to imagine it like this. All right? That I'll just erase the x's out of it and leave them as just empty blank spots. Why would I do that? Well, because sometimes people get the x plus h and the x there confused with the x there, and there's x's everywhere. So I'll just, maybe it'd be better to put it that way. And see this thing right there, the x plus h, that goes here and it goes there. If you were going to plug a number into this function, wouldn't you put it here and there? Yeah, that's where the input goes. Okay, so we'll get x plus h squared plus 2x plus h minus 1. That's what it looks like if you take this input and put it in that function that was given. Okay, well, let's work this out and simplify it as we can. I mean, that's what's going to go up here in the difference quotient. It's going to be this part, but we're going to have to simplify it anyway, so I'll just go ahead and do that now. What is x plus h squared? Well, to square something means that we'll multiply it by itself. So it means x plus h times itself. What about this 2 times x plus h? Well, that we just distribute the 2. And what about this minus 1? Well, it can't be combined with anything, or it can't be canceled, so we'll just have to leave it. Now, how do you take these and multiply them? We do first x times x, outside, x times h, inside, h times x, but that's the same thing as x times h. Last, h times h, which is h squared. Okay, so now we've got that. All right. Can anything be simplified, canceled, added? Well, x plus h plus another one. Those are like terms, so there's 2. So x squared plus 2xh. And then nothing else can be added or canceled. Okay? All the terms are different. None of them are the same. All right, so that's f of x plus h. So what I've done for you so far is we got this function. I found the f of x plus h part. So let's assemble the rest of it all together. Okay, so just a minute ago when I did f of x plus h, here's what I got. X squared plus 2xh plus h squared plus 2x plus 2h minus 1. So that's f of x plus h. Then there's this subtraction right there. And remember how I said before that that minus applies to this whole thing? F of x, yeah, that. So I'm going to draw with my red pen that parentheses just for emphasis. What's f of x? It's right there. X squared plus 2x minus 1. Okay. There it is. Over h. Now I've got everything there in the difference quotient. This whole part, that's f of x plus h, which I worked out on my scratch paper. This part is f of x, and that's h. Everything is there. And we just have to see, does anything simplify? Well, I hope some things cancel out of this. Let's see. I'm going to have to just copy all that down and apply that minus through this whole thing. Okay? All right, so let's see. X squared plus 2xh plus h squared plus 2x plus 2h minus 1. And if I apply this minus through this entire thing, the opposite of x squared, that's negative x squared. The opposite of 2x, that's negative 2x. And the opposite of negative 1 is positive 1. Okay? Now there's a lot of stuff there, but we should see that some of it cancels. Let's see. Positive x squared, negative x squared. Okay? Let's see. Positive 2x, negative 2x. Negative 1, positive 1. So a fair amount of it does cancel. What's left? What didn't cancel? 2xh plus h squared plus 2h. That's what didn't cancel. Okay, now what? Here we need to do some more canceling, but it's tempting to think that we can cancel this h with this h. That's tempting, but that would also be wrong. A lot of things in algebra that are wrong are also tempting, all right? So can we just cross those out? No, we cannot just cross those out. Think of it like this. Could I break it down this way? Could I break it down like that? I can. Okay. More important question. How do you know I can take this and break it down that way? Well, think of it like this. Can you add fractions that have a common denominator? You can. And then how do you add fractions with a common denominator? Well, these three fractions have a common denominator of h. So you take 2xh plus h squared plus 2h all over the common denominator. So you can go this way, right? Because that's how you add fractions. So that means you can also go that way and take this and break it up that way. Now, I'll show you it that way so you realize that what this means, that bar right there going all the way across, means that each term there gets divided individually by h. Okay? Now, one at a time, we see that the h cancels there, and I'm going to get 2x. And what's h squared divided by h? How did that cancel? Well, that's going to give me an h. Okay? And then 2h over h, that's going to give me a 2. All right. I don't know what that was, but anyway, 2x plus h plus 2. That's the simplified result of the difference quotient. Okay, just get your canceling right. Make sure that you don't do things that are tempting but wrong and just cross that out and have nothing else. Got to break it down this way. Okay?